Changing a consumer unit is one of the most important jobs an electrician can do because all of the power for your entire house goes through this box. So today we're going to show you step by step how to change a consumer unit in the best possible way. Because over the years I have seen hundreds of not neat consumer units. Not neat, but often also not safe. So in this video, we're going to be ripping out this old consumer unit and replacing it with a brand new one, and we're going to talk you through step by step exactly how we do it. Now let me be clear on one thing, this video is not intended to teach DIYers how to change their own consumer unit. To change a consumer unit, you need to be a qualified electrician, you need to certify the installation once you've changed the consumer unit, and you need to provide a building regulations certificate. That means that it should only be done by a qualified and competent electrician who's able to issue the correct paperwork. That being said, this video will help trainees and learners or existing electricians to learn some tips and tricks to improve their own consumer units, and it will also help you if you are a homeowner looking to get your consumer unit upgraded to know what a good consumer unit change looks like. So let's get into the video. So this particular consumer unit is about 20 years old. This house is built about 20 years old. The reason we're changing it is several reasons actually. One, it's an old plastic consumer unit, which the modern regulations suggest that they should now be metal. Two, all of these circuits do not have RCD protection, and they should now according to the regulations. Three, there is no surge protection device in this consumer unit, and according to the latest regulations, there should be. Now, all of this means that this consumer unit really is out of date and it is time for an upgrade. But the reason we came out here originally was actually to do a fault find, and you might recognize this if you're a regular viewer. This is the place where we had the crazy live plasterboard on the ceiling problem. So since then we've done an EICR, which stands for Electrical Installation Condition Report. That's what this sticker is all about, and we always do that before we change a consumer unit. And make sure you stay to the end of the video where I'm going to tell you a story about why we do that, because I learned the hard way that that's important to do. So we're going to jump in, strip this one out, and I'm going to talk you through step by step what we need to do to upgrade it to a nice fancy new one. Cut that, it's 30 years old, this house, so it's definitely due for an upgrade. Now step one is actually something you might not think about, but it's really important. Prepare your workspace. There's nothing worse than having stuff strewn everywhere and trying to crawl around to find stuff. So what I'm going to do is clear myself some space here, get my folding table set up, get my materials laid out so that I can be efficient in the way that I work, have all the tools that I need to hand, and hopefully that'll make the whole process go a little bit smoother. By the way, we're on a mission to hit 1 million subscribers, and every person who hits that subscribe button, it really helps. So if you haven't done so already, thank you for subscribing. Now I always like to put dust sheets down. Although this is a garage and the floor is already quite dusty, it's quite handy just to have a dust sheet on the floor to catch any little bits and pieces that drop. Rather than having to pick them up one by one, you can just pick the dust sheet up, gather all of your bits, and then shake it out into the bin. I'm going to set this up. This is probably one of the most useful tools that we have in our toolkit because it gives you a nice waist height working space to keep all of your tools and bits and pieces, and I'll leave a link in the description below where you can get one of these from Amazon, and it helps support the channel. Now in terms of tools you're going to need to do this job, here's a good list. Impact driver to fix the consumer unit back, not to do the terminals up. An SDS drill to drill your fixings to fix the consumer unit back. A marking kit to mark your holes. A level to make sure the consumer unit is level. Of course you're going to have the power off, so you're going to need some light, and I'll leave a link in the description below where you can get a discount on all Unite work lights. They're fantastic. You're going to need some measuring kit to make sure that you get everything installed in the right place and it all fits. A hammer to hammer your various raw plugs into the wall. Of course, some safe isolation kit to make sure that the consumer unit is dead before you start changing it. Some safety glasses, a knife, various hand tools such as side cutters, pliers, and these installation pliers, which I absolutely love. And very important but quite controversial, a Torx screwdriver set. So that's what we need in terms of tools. Let's get stuck in. Now step 2, before you turn the consumer unit off, is ask permission from the customer. So Alan, is it all right if I turn the power off?
Yes, fine.
Great stuff. And when we turn the power off, what we tend to do, rather than just turning the main isolator off with everything live, we'll turn off the individual circuit breakers first, like so. And then, once they're all off, there's no load on the main switch, then it's safer to turn the main switch off. Now that we've turned the main switch off and all of the outgoing circuits are off, you might think, well, it's safe to work. But it isn't, because these tails that come in from the meter box are still going to be live, and we're going to have to remove those to swap out the new consumer unit. So we're going to have to go to the meter box and turn off the main isolation switch for the property, and then we're safe to start ripping this out. Now, when we do turn customers' power off, in this modern day of working from home and stuff like that, it can be quite inconvenient, especially when a consumer unit replacement often takes the whole day. So this Jackery power bank, or other power banks of different brands that we use, are really, really handy, because we can plug the customer's router in there, any other essential devices. And we've also, I've got two here, so I've got the studio light set up running off of this as well. So if you want to get yourself one of these, we'll leave a link in the description below. So in order to be completely safe here, we're going to have to turn the main isolator off in the meter box. Let's go and do that now. In every modern home, there should be the following items: a main cutout fuse, in this case it's 60 amps, then a set of tails that goes from that to the electricity meter, and then from the electricity meter to a main isolator switch. This isolator switch, when we turn it off, will isolate or switch off those main tails that go into the consumer unit. Now, if you don't have one of these, then the best thing to do is contact your energy supplier and ask them to fit a main isolator switch. They should do that for free or for a nominal fee, and it means that the electricians who come and change your consumer unit can do it safely without having to pull the main fuse or call out a company who needs to pull the main fuse out for them. There's a lot, it's kind of a grey area as to whether electricians can pull main fuses or not, so you can debate that in the comments. But if there's a main isolator, that is by far the safest and best situation when changing a consumer unit. So we're going to switch this one off, and then we're going to test in there to make sure everything's dead. So the next step is what we call safe isolation procedure. That's where we test to make sure that these tails coming into that main switch are actually dead and that there's no power in this consumer unit. For this, I'm going to need two things. The first thing I'm going to need is this. It's a GS38 approved test instrument. Basically, it's a voltage indicator that allows us to test whether there is voltage at a particular place. So in this case, I'm going to test between line and neutral on my main switch. But first, I need to actually prove that this thing works properly. And I'll show you the easiest way to do that with a proving unit. Is you're going to prove that your tester works on the proving unit. And with this one, it counts down all the way through the various voltages. So we know our tester works. Then we're going to test to make sure it's dead. And we're going to test all three combinations. So that's line to neutral, neutral to earth, and line to earth. Three combinations for single phase supplies, but there's a lot more if it's a three-phase supply. Then we're going to test again to make sure our tester is still working, and it is. So now we're confident that this supply is dead and we can start working safely. I'm changing identities today. It is absolutely freezing, so I've got three different beanie hats to wear. I've got my personal one, I've got my Artisan Electrics one, and then I've got my Hilti one. I think that should keep me nice and warm. Just for the good looks on camera, I'm going to take it off because my head is really hot now. Right, so the impact driver comes in really handy now. What we're going to do is just strip this old consumer unit out, and it's just quick and easy to do it with an impact driver. But first, before you touch or change anything, I urge you to do this, right? Take a picture of before. Because there's a few things you're going to need to think about here. For example, how many wires were in each circuit breaker? What size wires? What order were they in? All of that stuff is useful to look back at. Just in case you have any problems, you can always look back and reverse things. The other thing is, obviously, we've done an EICR on here already, so we know what circuits do what, etc. And there's a really good reason for that, which I'll explain later. but basically we just want to make sure we've covered our backs. And also, to be honest, if you're an electrician and you're not posting your work on social media yet, you really need to, because it is by far the best way to get really good customers these days. So what I'm going to do actually is I'm going to do a before and after photo for our socials. So I'm going to take a before photo, boom, like that. We'll take one with the cover off, and then when we've changed the consumer unit, we'll do an after photo. We can post it on our socials, and it's a great way to showcase your work to future customers. So, what I've just done there is literally loosened all of the screws in this consumer unit so I can remove the circuit breakers. Now, I didn't tell you this earlier, but another reason why we're changing this board is that actually there was a faulty 6 amp circuit breaker. So we've had to combine both lighting circuits onto one temporarily. So that's another issue that will be solved. You might wonder, what do we do with these old circuit breakers? Well, you can actually recycle them. There are some companies who will buy them off you for a nominal fee. So if you've got a massive stash of old circuit breakers lying around, rather than just throwing them away, worth to try and recycle them by selling them to like a used circuit breaker company. I'll leave a link below to one that we use, which is quite useful sometimes. Now, there's a very important step that I nearly forgot, and that's actually labeling up your wires from your circuit breakers before you remove them, so that you know which circuit does what. Now, in a fairly small consumer unit like this, it's not too bad if you forget, because there's not that many circuits. We've got 2 ring circuits, so that's basically sockets back of the house, sockets front of the house, and then we've got 2 lighting circuits, lights upstairs and lights downstairs. However, these cables really nicely, kudos to whoever did this 30 years ago, right? They've actually labelled the sheath of the cable with little bits of writing. So we've got ring 1, ring 2, up lights, down lights, WH. Oh, and I've just realised something. I take back what I just said about 30 years ago. I bet that's Lee when he did the EICR. That is a Lee touch. And the reason I know is because he's put NV on this cable. When he did the EICR, he wasn't sure what this circuit was, so he's put not verified. We did find out later because we left that circuit off and the customer said, oh, my washing machine's not working, so we knew that that was the washing machine circuit. But thank you, Lee, not thank you, electrician from 30 years ago, because this is really going to help me when I do the board change. And you know, this is the kind of great thing about our team, is that, you know, we help each other out. We think ahead of what would I want somebody to do if I was changing the board. Everything's labelled already, so I can throw my tape away. But if you are doing this and you don't have an amazing person like Lee who's done an EICR beforehand, what I would do is just put tape around the circuits, right? This is how I do it. Obviously there's different ways of doing it, but I just wrap a little bit of a flag of tape, and then with a Sharpie or something like that, write what circuit number it is. So this one is the one that says not verified, so I know it's washing machine. So what I'm going to do is just put WM on there, and it was circuit number 3, so I'll put /3 with my terrible writing. It gives me a good idea of what is what. So little tip for you, always label up the wires beforehand. That way you don't have to go out and figure out what does what afterwards. And also with the rings, you want to know that you've got the 2 legs of the ring in the right circuit breaker. If you've got 2 rings and you muddle them up and cross them over, it's a bit of a disaster, although you can test to verify that, which we'll show you in a bit. So now I'm gonna whip this board off the wall. And the consumer unit is off the wall. So this is the new consumer unit that we're fitting. We've gone with a fuse box consumer unit today. We fit quite a lot of these. Our main 2 go-to brands are Hager and Fusebox, to be honest. And for most situations, Fusebox is good because it's good quality. You know, we've used them for a long time now. We've not had any issues with them. Reasonably priced. Also, they do double pole, single module, mini RCBOs, which is really important for us, especially when we do a lot of EV charging installs and solar installs. They do bi-directional RCBOs as well. They also do AFDDs now, and AFDD stands for arc fault detection device. We don't use them very often, but sometimes it's needed with the regs. For example, if you're doing a HMO or a care home or something like that, certain circuits are going to need to be on arc fault devices. We've gone with quite a big consumer unit. It's a 21 way. The reason for that is that, to be honest, you don't pay much extra to have more ways. You know, it's very minimal, the cost of a slightly bigger consumer unit, but if you ran out of space and had to change it after a few years, that would cost a lot more. So we prefer to just future-proof things, put a nice big consumer unit in, because it doesn't make much difference to the cost in terms of the size. And the other thing that we're doing today, because these cables are surface mounted, we're going to fit a standoff bracket to enable us to bring the cables into the back of the consumer unit. So in here we have our standoff bracket. Now there's this really dumb thing that Fusebox has done, is that although it's a 21 way consumer unit, they number the standoff bracket 24. I think that's because it's for a 24 module enclosure. So you've got 2 modules for the main switch and 1 module for the SPD. But sometimes it's confusing because you can easily get the standoff bracket that's too small for the consumer unit. So always double check which parts you've ordered. So this standoff bracket goes on the wall like so, and basically then you can knock these out, take the cables down the wall inside there, and then knock out some knockouts in the back of the consumer unit to bring the cables in. We've got a bit of a problem here though, because I think because we're using a bigger consumer unit and these cables are not very long, we're going to struggle with length on these cables if we leave the consumer unit at the same height as it was before. So what I'm tempted to do is actually move it up slightly, replace these main tails because they're probably not going to be long enough, and then we can actually have plenty of length on the cables to tie them in neatly into the consumer unit. So in the box you've got these 2 accessory packs. So I'm going to show you what's in those. Make sure you don't lose these because there's some quite important little things inside these accessory packs. So this one has 4 screws. Those screws are the accessories from the standoff bracket. So they're going to enable you to screw the consumer unit back onto the standoff bracket. So they basically go in here like that. So you fix the standoff bracket to the wall, and then you fix the consumer unit to the standoff bracket. Then in the consumer unit accessory pack, we have a label kit, and I'll be honest, we don't really tend to use the labels that are provided. And then this is, let me know in the comments what it's called, because some people call it a Busbar and other people call it a bus bar. And I have learnt over the years that the correct terminology is, drum roll please, Busbar. So that is our Busbar, and that is basically going to distribute the power across the bottom of all the circuit breakers. I think we're going to probably have to replace our main tails in order to get more length. So what we'll do is just chop out the cement here. There we go. Those are nice and loose, so hopefully we can pull in a new set of tails on these existing ones and then just reseal that hole. Now, because the height of this consumer unit is just a little bit above arm's reach, I'm going to actually use this step ladder. It's the smallest one I've got, unfortunately. I could do with a little hop up really, but I'll be honest, I feel like I'm cheating a little bit here, because actually this is probably the easiest place ever to change a consumer unit. I've chosen this one because it's nice and easy to film. We've got plenty of room to show kind of an ideal installation, but often if you're an experienced electrician, you'll know it's going to be under a small cupboard, under the stairs, or in some kind of really awkward place. And actually that's where this comes in really handy. So if you're working in small cupboards under stairs, this pop-up stool can be really useful, because you can just sit at a nice height and work like that without having to sort of lay on the floor or be on your knees and hurt your knees and stuff like that. So as with all the tools today, we'll leave a link in the description below for one of these. Absolute game changer for working at that sort of kneeling height for electricians or other tradespeople. So another thing you can do if you don't have enough length on the cables, it's always good to check, is just give a little pull on them, because sometimes the installers will have left a little bit of slack in the wall or something like that, and you can actually get a little bit of extra length on them without having to change the height of the consumer unit. In this case, there's a little bit of play on some of them, which is good, but I definitely think it's still going to be necessary to raise the consumer unit up somewhat. So what we're going to do is fold these up to about there, get rid of these clips, and then we'll put the consumer unit at about this height, which means that we've got plenty of length on those cables to dress them in really nice and neatly. So what I'm trying to do when I choose the location, there's multiple things that I want to take into consideration. Obviously it needs to be level. It needs to be nice and smooth surface, so not uneven, so that I've got good fixings. And I want to be drilling into brick rather than the mortar if possible. So I'm spacing the fixing screws either side of the mortar so that we've got 4 solid fixings for this. Obviously I'm looking at the height of the cables where they come in, making sure that the knockouts line up correctly. But also I want to actually line up the knockouts for the tails directly above the hole, so that we can dress them in a nice straight line straight up, and then they'll go up and into the main switch. Now once I've made sure it's level and it's in the place that I want it to be, I'm going to put 4 dots with a permanent marker on the wall. Then we're going to drill a 5.5mm hole with our Hilti SDS drill. So now I'm going to offer it up again, just to make sure that all my fixing holes line up with these kind of silicon blocks. They're not the nicest to drill, so you can end up moving the drill a little bit from one side to the other, but these look like they've lined up okay. And now what I'm going to do is mark the knockouts that I need to take out in order to get my cables in. I think we can probably get away with just 1 knockout for those. And then here we've got a lot more cables. So we've got 4 twin and earths, and we've got a green yellow earth, so I'm going to knock that one out, and then I'm going to knock this one out for our main tails, and then we do have this earth for the gas, so I'll probably knock out one of the far left for that one. So now that those are all knocked out, we can get this on the wall. And what I'm going to do is put it over these cables so that they're already through and in, then I can line them up into the correct knockouts. Now a little tip I learned from an old Sparky is don't try and line up all 4 holes, just line up the top right corner, get that 1 screw in, and then you can adjust it from there and get your other screws in, and that'll make it easier for you to just line everything up. And don't put all 4 screws in all the way, because what you want to do is get it level and then button them up finally. So I've got my left hand screw in there now. If I get that level, that is now bob on, then I can put my final 2 screws in. A little tip for these magnetic levels, sometimes they can get a bit of dust under them and then it looks like it's level, but it's actually not. So I've just shaken the dust off and I've found that it is slightly out. So what I'm going to do is just refix it. So now that we've got our top cables in, we're going to get the bottom cables in, and to do that we're going to have to replace these tails. So we're going to whip these out of that main switch on the other side and then run in some nice new flexi tails which are going to be easier to work with. So generally these main isolator switches have a bottom cover that you can't access. Often they'll have a seal on there, and that basically means that this side, which is permanently live when the main fuse is in place, you can't get to. But this is the consumer's side and you can take this one off. So I'm going to whip the cover off this, pull these 2 tails out and then slide some new tails in. So these are the lovely flexi tails. Doncaster cables make, in my opinion, the best quality cables, so we always use them, but there are different brands of flexi cables that you can get. We buy them in these 25-meter drums now just because we use them so much. We can just keep them on the van and cut them to the right length. You can get these like 3-meter, 5-meter packs, but then the pack itself is very expensive. There's obviously a lot of copper in these, so they are quite expensive, but the pack is expensive, and if you buy a 3-meter pack and you only need 2.5 meters or 2 meters, you end up with a lot of wastage. So we found that just getting these little 25-meter drums is the most cost-effective way, and then you can cut them to length. You've got way less wastage and you save a little bit of money. So those are through there. they're going to go up and into the main switch. So I'll cut those to the right length and bring them up into the board. This main earth, I was hoping it would be long enough, but it's not going to be. So what I'm going to do is cut this in the meter box, install a main earthing terminal in the meter box, and then run a new bit of 16mm earth through with these tails to the main earthing terminal. So these are our flexi tails, as you can see there. They are what they say on the tin, super flexible. So I'm going to pop those into the main switch here. That means I can slide back any slack and it'll be just exactly the right length in here. So it's really important that you get the polarity right when you connect these in. Now if you see on the right hand side just underneath there's an N on this side, so this side is the neutral. So you want to check that the neutral, which is the blue, goes into the meter, out of the meter, into that right hand side, and then going out you're going to connect your neutral out of the right hand side of that main switch as well. So this is what we call a torque screwdriver. It allows you to set it to a particular torque that matches the manufacturer's specifications, because terminals that are carrying a high amount of current like these are by manufacturer's specifications designed to be tightened to a certain torque setting. Now this little set is a Draper set, so on here you've got your torque setting. Here it says 2 and here it says 3. If I pull that up and turn that, I can then set this to 2 Newton meters, for example, or I can turn it and set it to 3 Newton meters. But the question you might be wondering is, well, how do you know what torque setting you need to set this to? On the side of the device, usually imprinted in the plastic, is a label that says the torque setting that you need. It's the same on circuit breakers, MCBs, RCBOs, the main switch in the consumer unit. I'll show that inside. This one says 2.3 Newton meters on the side of it. So what I'm going to do is just set my torque screwdriver to 2.3, and then what you do is you tighten it as normal, and when it gets to the right torque you'll hear it click. Hear that? That's clicked. Now we know that that is at the right torque setting. So we're going to terminate the line conductor in the same way. I know that some Sparkies say torque screwdrivers are completely pointless. A lot of Sparkies have never owned one in their lives. Other Sparkies insist on them. Some well-known people say there's no such thing as a torque calibrated arm. I've sort of been in both camps over the years, but the more we've done renewable energy installations like battery systems, inverters, etc., and in EV chargers, the more it's become a necessity, because often manufacturers want you to prove that you've set the correct torque setting on the fixings by taking a photo of you actually doing it. So for me, I've just kind of owned the fact that we need to be using torque screwdrivers now, and at least you can say, well, I did tighten it to the correct torque and I do have a torque screwdriver to prove it. So those are both in now, and I'm going to pop the cover on and then we can start doing the other end. Now that our tails are through and our earth cable is long enough, we can pull out this old earth cable that can go. We're going to knock out the knockouts from the back of this. Now you might think it's only worth to just knock out the 2 that we need, but actually for future proofing I'm going to knock out all 3 and put grommet strip in all 3, because if any electricians want to add more circuits later, it's going to be really tricky for them to knock these out and put grommet strip when it's all fixed up and connected. So this just makes their life easier in the future, and we like it when people make our lives easier, right? So watch. Now I love it when brands make knockouts that actually knock out. This grommet strip is absolutely delicious. Once you get one edge in, it goes on really nice and easy. Yeah, so a little tip here, you're going to have to kind of persuade it in a little bit to make sure that the corners are fully in. It'll make sure that the entire thing is the right length. Oh, look at that, it's the perfect length. Our cameraman's too young to understand this. I was just saying, it's brass monkeys, which is Cockney rhyming slang for like it's really, really cold. But usually Cockney rhyming slang sort of makes sense, like up the apples and pears means up the stairs. Brass monkeys, I don't know what the reference is, so let me know in the comments, why is it brass monkeys? I'd love to know. 2 million hours later, after much wrestling, I've managed to get the grommet strip in, but that is solid, that is not going anywhere. So this is now ready to offer up there. We can then pull our cables through, get that fixed on, and then we'll talk about how do you choose how to lay out the cables within the consumer unit. Now, one thing that's really important to get a consumer unit neat is actually making sure the wires are nice and straight, but that's not always easy when you've got existing cables that are a little bit kinked. And a little tip that I've always used is just use your sleeve, or ideally like a microfiber or something if you've got one, or a cloth of some kind. Just rub your hand along the cable, warm it up, and when it's warm, it's a lot easier to get it nice and straight. For this cable, for example, I've now got it nice and straight, and I can get it into the board and then just clip it up to hold it in place, and it kind of looks almost as good as new. So now we can take this enclosure for the consumer unit and just slide the cables through in the relevant holes to line up with the circuits, how they're going to be laid out. So in this case, I'm going to take the main earth and the tails through the right hand side one, and I'm also going to take all these cables that are going through the top on this side through this same hole, shove them all through like that, and then these ones through the middle, and then we'll leave the left hand opening completely free for brand new circuits. So that it's going to slide up like that. Now all we need to do is install these 4 fixing screws. And the nice thing is about these, you can actually fix them into the base, and then you can pop the board over it. They fit in those little wide openings under the bottom of the fixing screw. Okay, so that's on. The first thing I do anyway, maybe you do it differently, let me know in the comments. But what I like to do is get the tails into the main switch because they're quite chunky, then get the main big chunky earths in to the earth bar because they're quite hard to work with. Anything that's hard to work with, you want to give yourself enough space, plenty of space to work. And then all of the other little fiddly cables are going to be a lot easier to terminate. I will cut both so that they both look like they're the right length. So the live is going to be cut to the same length as the neutral, and that should enable me to terminate them both nice and neatly. Right, so a little tip for you guys on this to make your life easier. You've got this cable like strain management thing here, which is really nice because it enables you to clamp the tails into place, and then even if the terminals come a little bit loose, they're never going to pull out. But it's a bit fiddly sometimes to get those through there and into the main switch. So what I'm going to do is just remove this, slide this over the tails like so. Then the main switch can just unclip from the DIN rail. So this thing here, this metal silver sort of rail, is what we call DIN rail. It's a rail that is of a standard size. I don't know what DIN stands for actually, so let me know in the comments if you know what DIN stands for. But basically it's the standard size for circuit breakers to clip onto. And to unclip this breaker, like the main switch from the DIN rail, you've got a little clip at the bottom there. You put your screwdriver in, lever it down, and then the thing just comes off. That makes it way easier because now I can just pop my conductors into the main switch like that. I can check that they're the right length and that they're stripped back properly and stuff like that. So I can see my line conductor is a little bit too long. Cut a little bit off that. Give yourself the best opportunity possible to do a neat and safe job. I'm not going to tighten them up fully. And can you see that there? 2.5 Nm. That is 2.5 Newton meters. That's the torque setting that I was telling you about. So the requirement for these main switches is that we terminate the cables to a torque setting of 2.5 Newton meters. Yeah, there we go. It's on the DIN rail. That's clicked into place. Now that's not going anywhere. And now what I can do, I'm going to have to pull these tails back just a little bit because I have cut them slightly too long. Screw that all the way back. That clamps onto the tails and holds them into place really securely. And then I can go in with my torque screwdriver and just torque those up. So now that our main switch is all buttoned up, torqued up, in place, let's talk about this. This is a surge protection device. Now this has come into the regulations in the last few years as a requirement for basically all properties, to be honest. Any property that's got sensitive electronic devices, which could be sensitive to surges, is required to have one of these. Think about it, we've all got expensive electronics now. You've probably got a TV, you've probably got a couple of smartphones in the house, maybe some tablets, stuff like that. Even our like washing machines and dishwashers and things like that have sensitive electronics in nowadays. So this device, which may be 100 quid's worth of kit, protects you from surges on the power lines and basically avoids blowing up all the electronics in your house. And every new consumer unit that gets fitted should have one of these, either in the consumer unit or at the main incomer where that main isolator switch is. Sometimes you can fit a main isolator that's got a surge protection device built into it. So that is the first device that goes in, and that comes with the consumer unit in this case. And then we're going to put all of our RCBOs, our circuit breakers, in place here and connect our circuits in. But first, we're going to get these earthing conductors terminated neatly, and then that leaves us just with these ones to terminate. So before we terminate the main earthing conductors and bonding conductors, we're going to label them up with some heat shrink tube. So I'm just going to label gas bonding, print that. There we go. So we've got our gas bonding there. Then we'll do the same for water bonding. There we go. And then we'll do one for our main earth. So in order to dress these in neatly, what I'm going to do is push a little bit of slack up behind this standoff bracket, because we've got room, gives us a little bit of wiggle room, and then do a nice neat swoop, leave it quite long into the E terminal on the far left, which is for the main earth. And then I'm going to copy basically the same kind of format for the main bonding conductors so that they're all pretty much the same length. So I'll start with the main earthing conductor and then copy with the rest. So what I'm going to do is get these in roughly. I'm going to tighten them all to the correct torque setting, because there is a torque setting on this earth bar. You don't want to heat shrink them before you've kind of offered them up, because otherwise you might find that your heat shrink, the text is on the back of the cable or something. You might say, well, what's the point in getting it neat? Nobody's going to see it, the cover's going to be off. But the thing is, every electrician who ever takes the cover off this consumer unit will judge the standard of your work by what this looks like inside. You know, we do it all the time. We do neat or not neat. And if a consumer unit has not been neatly done in general, for me, that indicates a lack of care from the electrician who worked on it. Imagine that this is like your calling card that you're leaving behind for the next person to see. You want to make sure you leave something that you're really proud of. Before you start with everything else, you just want to make sure that your RCBOs will fit underneath those main conductors. If you have them too low, like if we had them sweeping down to here, it would block access to be able to connect circuits in to circuit breakers that were here. As it is, this is absolutely perfect, so spot on there, but it's always worth to double check. So these are all our circuit breakers that we've got to go in for our various circuits. They're RCBOs. Now this is what we call an all RCBO consumer unit. There do exist consumer units that don't have a main switch and RCBOs, but rather they'll have multiple RCDs protecting several circuits. But really those are not allowed anymore, because you should not have multiple circuits off one RCD. It can cause a lot of inconvenience in the event of a fault, because if there's a fault on one circuit, it knocks out the RCD and trips multiple circuits. Whereas RCBOs like this, that one RCBO provides RCD protection, overcurrent protection for that one circuit. So if there's a fault on that circuit, you only lose that circuit. You don't lose all the power in your house, which is much better. And now with the amount of earth leakage that can build up from circuits, we find that because there's so many electronic devices on circuits and they often all give a little bit of earth leakage, you can get nuisance tripping if you have multiple circuits on one RCD anyway. So now what I'm going to do is unpack these decide whereabouts I'm going to lay out these breakers, because that will dictate where I strip and dress the cables for these particular breakers. So I've unpacked the RCBOs from their packaging. We just need to straighten out all these little tails. We've got 3 32s, 2 16s and 2 6s. And what I generally try to do is put the higher rated breakers as close to the main switch as possible and then work down to the lowest. I think that's kind of an old school way of doing things. Let me know in the comments if you do that. It doesn't really matter because the bus bar is capable of handling the power all the way along. So what we might do is look at where the cables come in and see if there's a neater way of doing it. But first we're going to get these untied and then get them all onto the DIN rail. So these are what we call flying leads, and they are the neutral tails that will go into the neutral bar. So from the first RCBO, it needs to go into circuit 1 neutral bar and then works its way along basically. And then these cables will terminate line and neutral into the top of the RCBO, and the earth will go into the earthing terminal here, and they need to all be in order. So the thing you've got to figure out is what order are you going to connect your circuits. So I'm going to connect the cooker circuit to the first 32 amp breaker. I think that's pretty logical. Then I think what I'll probably do is we've got 2 radial circuits here, and then 2 lighting circuits. I will probably just go in order of the cables because these ring circuits can go on the end. I'm not particularly worried about doing those a little bit further along the bus bar. So I'm actually going to take these 2 32 amp breakers and I'm going to pop them on the end, and then that is going to basically enable me to have all the cables in order as they come into the board. So it'll sort of make sense as I start to dress them, but basically that's how it's going to be. So 32, 2 16s, 2 6s, and then 2 32s for the ring circuits. I think that's a nice way of doing it. And then all of these empty spaces we're going to fill with blanks so that the front of the consumer unit is completely sealed and there's no gaps where people can get their fingers in and stuff. What we got to do is dress these neutral tails in nicely first into this neutral bar. Then that gets those out of the way. But I think first I'm going to strip these cables back and then straighten them all, get them all nice and neat so that they're ready to button up as well. Now there are various ways to strip twin and earth, or twin and CPC as some people call it, cables. The traditional way that a lot of Sparkies will know is to basically use the earth and pull it back like that. And as long as you make sure it's in the middle of the cable, it'll strip nicely without damaging any of the inner cores. Now, I'll probably get people hating on me in the comments for doing that, but I think most Sparkies who've been doing it long enough will say that they've stripped twin and earth like that their whole life and they've never damaged a cable doing it. That being said, there are more professional ways, like using a special twin and earth stripping tool like this. So I'll show you both ways and then you can decide which way you want to do. For me, the disadvantage of this is it's hard to get close enough to the back of the board to strip all the way back. So I'll show you. I'll take this as far back as I can, and when I pull that will sort of break the sheath, but it's because it's old cable, it's quite hard to strip. So even then I'm realistically going to end up using the earth to just strip through up to that point, and then I can peel the insulation off like that. The black is the neutral, obviously the red is the line or live conductor. Now if you're using more modern cables, it's going to be harmonized colors, European harmonized colors, which we use now, blue for the neutral and brown for the line conductor. Earth wires in the UK here are bare copper inside the twin and CPC cable. So it's just bare copper, and then we sleeve it with some green and yellow sleeving, and I've got a little tip to share with you about that makes a big difference when it comes to neatness. Now another little tip for you, obviously now that I've stripped back these cables, we've lost our cable markings. So what I'm doing on the ring cables is I'm just doing one line in kind of Sharpie for ring circuit number 1 and 2 lines for ring circuit number 2, so that I don't forget which one's which. And then with these others, I'll do something similar. I'll put some kind of marking on so that I know which circuit goes where. So one of the keys to getting a really neat consumer unit, especially when you've got old cables like this, is actually straightening the wires properly. I've got various techniques. My usual technique is the sleeve technique, or you can use a microfiber, and it's particularly helpful when it's a cold day like this. Just rub your hand along it like that, warm it up, and then run your hand all the way down and put some pressure on it, so you kind of bend it between your fingers and thumbs like that, and you can get it really nice and straight. It sort of does my head in when I see electricians doing consumer units and the wires are all sort of like wavy like that where they go into the breakers. It's really not necessary. You can straighten these up quite nicely. But I did buy a tool off Amazon to try it out because I saw somebody using this on social media. Apparently it's a wire straightener. What we want is a nice neat loop like that with no kinks. So this tool, you basically put the wire inside the rollers like that, and then you roll it down, and actually works quite well, other than this last bit which sort of flicks through the roller and doesn't particularly work very well. But I think that's quite handy actually. Let me know in the comments if you've ever seen one of these. I will leave a link below where you can get one. What I might have to do is use my hand for the last bit, just to make sure that last little bit is nice and straight, but overall not bad. So you've seen how I straighten the wires. What I'm going to do is go through and straighten them all, get them as straight as I can, and then I can get them in order, cut them to the right length, and from the first circuit all the way through to the last, we'll connect them in, make sure all the loops are right, like the same length, and they look really light and neat. So let me get these straightened up and then I'll jump to the next segment. So all of the wires are now straight and neatly bunched, including the CPCs. And what we're going to do now is kind of separate everything so that the line and neutrals are ready to go into the breakers and the CPCs are up, ready to dress along and into our earth bar. So I'm going to start with the cooker circuit because that is going to be circuit 1. And what I literally do is just raise the earth up like that. And then that leaves me the line and neutrals down here. What I then tend to do with these is sort of tuck them down behind the DIN rail so that we give ourselves a bit of slack. There's no point in cutting them super short because if you ever need to change things around later, you shoot yourself in the foot. And then we do a nice neat loop over the top of the breaker and into the line and neutral terminals in the breaker. Once you've done the first one, you kind of set the standard for the rest. So you want to make sure that the height of the first one is doable for all of the rest of the breakers. So the height of the loops of cable are all the same height. And if you've got one particularly thick cable, you might want to bear that in mind because you're going to have to do a slightly larger loop on that. Otherwise it's going to be a struggle to bend it. So fortunately my first circuit is my thickest cable with this 6mm for the cooker. So I'm going to set that as the standard and then work my way along. But I think before I do that, I'm going to dress these neutral fly leads in so that they're out of the way as well. So same with the neutral fly leads, we just run our fingers along them just to straighten them up nicely. And with these, you can just sort of bunch them all up, but you're going to want to terminate them into the neutral bar first so that you know that the right ones are in the right terminals, if that makes sense. And I always struggle to know whether to tuck them behind the tails like that or to go over. I think in this case I'm going to go behind the tails. Basically then we can loop in, terminate that into that first slot for circuit 1. Give ourselves a nice little loop like that. We'll leave the slack for the moment and we'll tidy that up later. And then we'll do the same with the next one. Tuck it behind the tails, tuck it in to the terminal, and then it's just rinse and repeat. So these neutral tails are all in now. What I want to do is make sure that where they're visible, they look really, really neat. So here where they swoop into the neutral terminal, I'm just going to kind of leave them like that. Then you've got this kind of bunch of excess which you need to hide somehow. So what I will probably do with that is just bunch it up together and tuck it in behind the main switch, behind the DIN rail. Now it might be helpful to kind of cable tie them together or something. Let me know if you've got a particular technique for doing this. Some people cut the flying leads short, but I've heard sort of mixed feedback about that, where some people say that they're actually designed to operate at a certain length and therefore you shouldn't cut them. The other thing is that they are like kind of ferrulized ends, like the copper has been compressed on the ends. So if you do cut them, then you need to put ferrules on the end because they are made of fine stranded copper. So I prefer to just leave them full length if I can, and then just neatly tuck all of the excess somewhere that's not really very visible, that's nice and safe, and it means that you've got access there if you need to rejig things later on. That is about as neat as it's going to get, I think. So as I say, now that we've got those dressed away, we're going to cut these two to length for that first breaker. So I'm going to leave them as long as I can, but we're going to have to shave a little bit off them, and we want to make sure that the line and neutral are the same length. And then, a handy little tip, on the side of these breakers, you've got a strip length indicator. So here it says strip length. That you can line up with your stripping tool. It doesn't say how many millimeters it is, but roughly pop that in there and strip these conductors back to the exact same length every single time. That is the advantage of having a proper stripping tool for these kind of situations. I know a lot of people might use croppers or something like that, but I do actually prefer to use a proper twin and earth stripping tool for stripping the ends, because you can get them exactly the same length that way. Gently put them into the terminals. Check that they look neat, check that there's no excess copper, which there isn't. We can see the Newton meter setting for these breakers is 1.2. So I'm going to set my torque screwdriver to 1.2 Newton meters. Now this is where you've got a decision to make. Do you swoop to the right, do you swoop to the left, or do you go straight backwards? Naturally, the wires will fall a certain way, but once you've got one set of wires coming into the breaker at a certain angle, you want to match that with all of the other breakers. So sometimes you can maneuver them a little bit. I think that looks the neatest, so we'll try to get it like that. So basically the wire comes straight over and into the top of the breaker directly from the back. I want them to all loop over at the same length, but I don't want all of this slack visible on all of these flying leads. But I reckon we can bunch these up and cable tie them like that. Now, when you've got 2.5 twin and earth or smaller, what I like to do is actually double the conductors over, just to give you a bit more surface area, especially when there's only one conductor in the breaker. So what we're going to do is actually strip it back, double the amount of length that we usually would. So we're going to say strip it to about there, and then we're going to double them over. It's just good practice. You'd probably be taught that in college if you've been to electrician college. So we get a pair of pliers like this, and we just double over the copper back on itself, bend it over like that, give it a nice squeeze, so you've got a nicely doubled over conductor, and that just gives you a bit more surface area, gives you a better connection usually than just having a single strand of copper. On the last consumer unit deep dive video that I did a few years ago, I used these Legrand cable labels, and it was a sort of a bit bougie. I'll be honest, we don't usually do this, but I thought, you know, it's quite nice to show like the creme de la creme of practice. So I thought I'd do that on this one as well. I got these off Amazon, and they're just these cable numbers. So you just clip them onto the wires. These come in these little packs of just like 10 of each number. The Legrand set that I had before was like insanely expensive, and once you knock it over and spill the letters everywhere, it becomes a little bit redundant anyway. So these are quite good actually, I'm quite impressed. I'll number up the other circuits later. Now we've got to start thinking about what to do with the earths, making sure that they're all kind of going to come out in the right place. So I put them up like this to keep them out of the way. We're going to have to put sleeving on them, and then we're going to dress them up and along under this earth bar, and then we're going to loop them in the same way that we do these, so that they're all the same length. But first I'm going to get these 2 lighting circuits in, so that those are in their relevant breakers as well. Then, to be honest, I'll probably do these breakers as well, and then all the lives and neutrals are in, and then I'll dress all the earths in together. So now all of our loops for our main circuits are in. We've just got our ring final circuits to do. So we've got 2 ring final circuits to go in, and the same principle applies. We'll just pop the earths up, then we'll tuck the line and neutral conductors behind the DIN rail, and then swoop them over into the breaker like so. But with these, because we've got 2 conductors going into the breaker, we're not going to double them up. So if you double them over and you've got 2, you will struggle to get them into the terminals. And because there's 2 anyway, it's kind of easier to get a nice clean connection on them. So now we've got all our line and neutral conductors neatly swooping into our breakers. They're all torqued up. I'm going to dress the earths in first, then I'm going to put the bus bar and the blanks in afterwards. So let me show you how I dress the earths. Right, now with the earths, there's a secret technique. So first thing you need to do, obviously, is make sure that they're all long enough. Now some of these, even though we've moved the board up quite a lot, they're only just going to be long enough. So don't cut them too short. The reason is they've got to go up, along and into the earth bar. So we'll leave those full length and we'll straighten them out nicely. These ones are absolutely fine, so that's plenty. So I'm going to just doubly make sure that these are nice and straight. But the secret technique is this, right? So this may just look like earth sleeving, but it's not just any old earth sleeving, it's 2mm earth sleeving. And it's a little trick that I learned quite a few years ago when doing consumer unit changes. It looks way neater if you use 2mm earth sleeving. It's just a lot easier to control the swoops of the wires and everything, and they, you know, keep them separate a little bit. It's a little bit harder to put on. I never used to have that problem with 2mm used to always fit fine. Seem to have a bad batch of 2mm earth sleeving. It's not going on very easily. And take 2. 3mm sleeving is an absolute game changer for consumer unit upgrades. Unfortunately, the 2mm sleeving that I had was a bit smushed. And so we're going to go with 3mm because it was too difficult to put on. But I do still agree that 2mm does look nice if you've got a nice fresh batch that you can put all your wires through, but 3mm goes on much easier, to be honest. Right, here's another tip for you. So when you're sliding the earth sleeving down onto the earth wire, how do you know what length? So you can try and measure it and then pre-cut it, but you end up usually getting it too long or too short. What I do is slide it all the way over until it butts up right to the end of the cable, and then bend it over like that where the copper wire is. Then slide that back by however much extra you need of copper sticking out. Cut it like that, and there you go. So we're going to double these up as well, like we did with the others. Right, so I've got all the sleeving on the CPCs, circuit protective conductors. I'm trying to do things correctly here, guys, and use the correct terminology, not that anyone else actually does in real life. What I'm going to do now is basically one by one dress them through to where they need to be. So this is the cooker circuit. So I'm going to go straight up from where it comes through, along the back, so you kind of tuck it right up, and then a nice loop into terminal 1, open that screw and bomb straight in to earth terminal 1. Once that's in, we decide what length looks right, and we get that one at the right angle. Then it's just a case of rinse and repeat with all of the other earth wires. Okay, so that is all the earth wires put away, and you'll see the principle is exactly the same as with the line and neutrals. We just try and keep them all in a nice loop and all at the same length basically, and I've just tried to tuck them up and out the way so that when you're looking face on at the consumer unit you can't really see them. So I think that's a nice result. And now what we'll do is pop the bus bar in and get all of the blanks in. When it comes to installing the bus bar, again there is a torque setting at the bottom of these breakers. It's 2.5 Newton meters. So be careful to remember to change the torque setting on your torque screwdriver. The bus bar lodges in underneath all of the breakers, and what it does is it takes the power from the main switch here, from the live side of the main switch, and it distributes it across all of these breakers here. Now it is possible to put the bus bar in the wrong way round. There's a thick piece on the first tooth of the bus bar. That's the one that needs to go in the main switch. The thin teeth are the ones that go into the bottom of the breakers. We did make a previous short video about that on our YouTube channel, but make sure you get it the right way round. It's really important that you make sure that each of the teeth from the bus bar is sitting properly inside the breaker terminal. Now with these ones you can't really get it wrong because there's no bit behind. You can see they've blocked off the bit behind with some metal, so you can't actually go behind the terminal, but in some brands you could end up being behind it and not realising, and that could be a loose connection, it could arc. So before we turn the power back onto all of the final circuits, we've got a few tests that we need to do just to make sure everything's safe after these alterations that we've done. Obviously we've replaced the main tails, so the first thing that we're going to do is a ZE test, or external earth fault loop impedance test, and we do that by testing from the main earth here to our incoming line conductor. Now obviously this is dead at the moment, so we're going to turn on that main isolator in the meter box. That'll liven us up to here, and then we can carry out that test. We're going to test between our main earth and the incoming live conductor, and we've got 0.2 ohms. PSC is the next test we do. That stands for prospective short circuit current, and to do that we have to reconnect our main earth, because we do that with all of our bonding conductors. So we're going to put that main earth back in. We're going to put our probe on here and then test between live and neutral. And we've got 1.06 Ka. We'll do EFC again now that we've got our bonding conductors connected, 1.01. So the highest is that first reading that we took, which was 1.1 Ka. We'll do a few tests to verify the continuity of the ring circuit conductors, because that's easy to do, and we just want to make sure we've not crossed over our ring circuits before we turn them on. We're also going to do our RCD tests, but we have to do those live. For this next set of tests, we're doing continuity tests. So we're going to null out our leads first. That's really important. So we just press and hold the test button, make sure that the leads are nulled out. We'll start with this circuit here. Disconnect these two CPCs, then we'll put our croc clips across them, and we should get a reading. So we've got 0.77 on that ring circuit. The other one is 0.64. Now I promised you guys I'd tell you the story about why we always do an EICR before a consumer unit upgrade. The thing is, it's so easy to just plunge in and change a consumer unit and then find that there are lots of underlying faults on the existing wiring. And I learnt that the hard way. When I first started up on my own, I was just doing consumer unit changes without doing an EICR, and then I test everything afterwards. But the problem with that is that you can do a board change and finish it at 4:30, 5 o'clock. You start powering circuits up and then stuff starts tripping because there are underlying faults on the wiring, and it's sometimes as simple as like the up and downstairs lighting circuits are linked via the stairs in the two-way switching on the stairs, it could be there's a borrowed neutral somewhere, or it could be that there are genuine faults. Now, when you change a consumer unit, you're basically taking responsibility for the installation because you've got to certify it at the end. And if there's loads of dodgy faults at the other ends of the wires, you're kind of taking responsibility for that as well. So we always do EICR first, then we know what the condition of the electrical installation is. We will then quote the customer for a consumer unit upgrade and remedial work if needed to rectify any other faults. And that means that when we leave everything in a really good condition, not just a new consumer unit with loads of shonky wiring. 0.38, 0.54, 0.55. That's good. So we verified the test readings on our ring circuits that basically they haven't changed since we did the EICR. That means that, you know, everything's connected properly at this end. There's not been any deterioration since we did the EICR, which is great. I've decided that these numbers on these lighting cables need to go because they're just not staying on the wires properly. So we're doing ZDB now, 0.28. We're going to do insulation resistance test. That is basically where we pump power into each circuit and check to see if there are any kind of short circuits or anything. Now, sometimes if there's connected equipment, we'll get a low reading, but actually circuit 1, which is the cooker, line to CPC, is greater than 999. Next circuit is the water heater, and for that one we've got greater than 999. So they're all greater than 999. So insulation resistance is perfect on all of these circuits. So what we'll do is we'll do an RCBO test on every circuit now to get the RCD test readings, and then we can turn the circuits on and make sure everything is working as expected. Moment of truth. We're going to turn the main isolator switch on. That livens up the bus bar, and then we turn each individual circuit one by one. First circuit we're going to test is our cooker circuit, and we're going to do an RCD test. This test is really good because it gives us an auto test. So it's going to trip 4 times, I believe. Maybe 5 times actually, because it does a ramp test. And the first test is at half times the rated current. So this is a 30 milliamp RCBO. So it does that at 0 and 180 degrees of the sine wave. Then we do 1 times. So for 1 times we've got 37.3 is the highest, and then our ramp test we've got 22.5 milliamps, which is great. 22.5, yeah. So 37.3 is what you're writing down, Lee, for the cooker. The next circuit is the water heater. We'll do exactly the same and we'll work our way along. So now that that is all connected, livened up, tested, there's just a couple of finishing touches that we need to do, and that is labelling. So we'll get the cover on and we'll get it all labelled up. If you're an electrician, brand everything is my recommendation. So we use these little bubble labels, we put them in the top right hand corner of the consumer unit. Looks really nice. Own your work. There we go. Take pride in your work and show that it was you. Then we put an inspection and testing label on the front as well, which tells that it was inspected and tested today, and it should be done again in 5 years' time. And then, of course, very important is the circuit labels to tell what circuits do what, and we're going to print those out with the Brother label printer. So that's it. One consumer unit fully upgraded to the latest standards. The customer's going to be a lot safer. They've got a certificate, which is for the electrical testing that we've done. They've also got a building regulation certificate, so everything's safe and compliant and up to modern standards, and they've got plenty of room for future expansion. So I hope you've enjoyed this video. If you have and you haven't subscribed yet, it really helps if you do. And why not settle back if you've enjoyed this video and watch one of the videos that's going to pop up on screen now that YouTube thinks you'll enjoy.